Kids, I'm here to explain the other one of the other parts of the review. Today we are going to start with friction wheels that are two wheels next to near and they rotate in the opposite direction, sentido contrario. Okay, as you can see here or here or here. Okay, the driver and the driver turns to the opposite side. Okay, applications. Well, no. First of all, there's another type of crazy wheels that have one crazy wheel in the middle. But what happened with this? Well, the same as in the other. One turns to one side, and the crazy turns to the opposite, and also the green is in the opposite side to the crazy. So always we have one wheel turns to one side, the other wheel turns to the opposite side. If it's one more, it's the same. Okay, applications to bicycle dynamos, Ferris arms transmission, transmisiones de las norias, turntables, que son tocadiscos, and more things. Okay, now it's the time to practice with the friction wheels. We have to calculate the angular speed of the driving wheel with the following data. The diameter of the motor one, the driver, is 25 centimeters. And the speed is 100 RPM. Okay? And the diameter of the driving, la conducida, is 10 centimeters. We have to indicate also what type of mechanical system is. First of all, we have to draw more or less the system, and you can see that the diameter of the driver is bigger than the diameter of the driving. So this could be a system, more or less. Okay. So now, seeing this, what type of mechanical system is? It's a multiplier. It's a multiplier because this one, the driver is bigger than driving. Okay? Okay, perfect. So, calculate the angular speed. We're going to use a formula that we see in the first video of the review. That this multiply the speeds with the diameters of both. First of all, the speed of driver multiplied diameter of driver is speed of driven multiplied diameter of driven. And the thing that you have to do is only to put the numbers in the where they have to be. 100 multiplied 25 is the speed of the driven multiplied 10. Okay, so we have to resolve, and the result is 250 RPM. Okay, okay, now another one. An internal friction wheel has an, sorry, I have to change this. Okay, internal friction wheel drive system has an I, that is the transmission ratio, that is 1/3. If the C, that is the diameter of the driven, is 15 centimeters, calculates the M. Easy. Calculates the M. Okay, we know this formula that we see also in the first video of the review. I is diameter of driver between diameter driven. So 1/3 is diameter of driver between 15, that is the diameter of the driven. So we can resolve in 5 centimeters. Okay. Now they say if the driving speed is 1500 RPM, which will be the speed of the motor. Okay. We can do it two ways. Okay, one way is the formula that we have here that we see in the first video. Step by step, and we resolve, and the number is 4500 RPM. But we can also do like this. We can also do like this. Yeah. We can do like this. E is speed of driving. So C between and of driver. So motor. Uh, here and then okay. Yeah. With this, we can do it also because we know the I and we know one of the speeds. So 1 between 3 is, yeah, 1500 between and the speed of the driver. It is no, well, this and then and m is 1500 multiplied 3. Okay, so it's 4500. You can see that you can do it in both ways. It's the same result. You can do it you want. Okay, you have both formulas, so you can do it both. In this case, because we have the transmission ratio. Okay. Okay. Another one is yeah, another I don't know why. Okay. Yeah. Another example of this, yeah, is this transmission mechanism consists on two friction wheels. The steering wheel has a radius of 40 millimeters and rotates at a speed of 100 rpm. You want to get a rotational speed of the driving axle of 25. What should be the diameter of the driving wheel? So the steering is the same as the driver. Okay, what we have to do? Well, first of all, yeah, to draw, and we can see that the driving axle speed is 25. So if it's 25 and the driver is 100, seems that it's a reducer. So the driver will be smaller than the driver. Okay? And to resolve with the same formula, the speed of the driver multiplied diameter of driver is speed of driver multiplied diameter of driver. 100 multiplied 40 is 25 multiplied diameter of driver. Resolve is the diameter is 160 millimeters. Okay, this is all of friction welds. Now belted pulleys. Belted pulleys is something like this. Two pulleys and one belt. Okay, as you can see, the difference between friction welds and belted pulleys is obviously the strap or the belt, but also another difference that is the directions of the wheels. In friction wheels are opposite, but in belted pulleys are the same, going to the same side, turn to the same side. Okay, as you can see here, there is a case that they turn each wheel turns to different sides. That is this case. In this case, when we cross the strap, we change the direction. Okay. Applications, well, washing machines, fans, dishwashers, polishers, videos, meat cutters, drills, electricity generators, lawn movers, motor transmissions. Okay. Here's an example of a washing machine. Washing machine have here the cycle where the clothes is. You put inside the clothes, and this have a strap rounding, and the other wheel have a motor move this wheel. Okay. Okay, so now here you have an exercise that you have in your homework. You have to say which side is going is turning the wheel. So here goes here in this side, and also this in the same side. This is a multiplier or reducer or anyone or no one, sorry. Yeah, it maintains the speed because the diameter of the wheels is the same. Okay, this one turns to this side and the other turns to the other side, to the opposite side. because have the belt cross. Okay, and this is as this is it maintains the speed. Okay, this one goes to the side, goes to the same side, and this is a reducer. Okay, because the driver is smaller than the driver. In this case, it goes in this side, the same side, and it's a multiplier because the driver is bigger. Okay, here goes to this side, and this one goes to the other side, the opposite side. We are going to see in a minute an example, an animate example. And this one goes to this side, goes to this side. So this yellow one goes to the same side, and this one goes in the opposite side. Okay? Okay. And here is the example I told you. I have to charge. Yeah. Here you have something more or less like the example that we have. It doesn't matter that this is with gears and the other is with pulleys. It's the same. And as you can see, this turns in one side, this turns in the other side. These two in one side and this in the other side. Okay? And also in gears, it's like in the friction wheels that you see that one turns to one side and the other the opposite side. Okay? And as you can see here, this is a speed multiplier because the small one turns faster than the bigger one. Okay? Good. Okay. Let's see an exercise and a problem of this. Okay. It has an engine that rotates at 1000 RPM with a pulley of 20 centimeter diameter connected to its axis, attached by belt to a 60 centimeters driving pulley. Represents the pulley system indicating the drive pulley and the driving pulley and the senses of arrows turn. Okay. Well, first of all, we are going to calculate the transmission ratio, and then, yeah, I have to change this also. Yeah. Nice. Perfect. Okay. Yeah. This is the system. Okay. The 20 is this and the 60 is this. 20, 60. Okay. The senses to both are in the same. The driver is the small and the driven is the bigger. Okay. Now to calculate the transmission ratio is easy. The relation with the diameters. So 1 between 3 because it's 20 between 60 and it's 1 between 3. Okay. Then to calculate the speed, we can do with this formula, resolving like this, or we can do it also with the transmission ratio. The transmission ratio of this 1 between 3 is the N2 between 1000. So the result will be 1000 between 3, that is the same as here, 333.3 period RPM. Okay. Here we finish the second part of the review. There's another part also with the other mechanisms. I hope you understand these things better than before the video. And see you next class. Bye.